Okay, so for 1b, it's kind of a similar process. So we have g of x equals square root of 11 minus x. So one rule in math is that square roots cannot be negative. If a square root is negative, then it will be an imaginary number. That's when you get an I. So let's write that down. And we don't want imaginary numbers. We want a real number. So now, in order to solve this, we have to look at it. So we have 11 minus x under the square root. We can take out the 11 minus x, right? 11 minus x, and we want to see when it will equal to 0, okay? Because once you know where it equals to 0, you can say from this point to another point, because we have to make sure that this 11 minus x is either 0 or positive. It cannot be negative because you can't have a negative under the square root, okay? So 11 minus x is 0, right? So we have that. It makes sense. So then we're looking at the numbers. We can plug in numbers to kind of test out what will happen. So 0 works because 11 minus x equals 0, and we solve for the x. So negative x, and remember what we did for this problem above, but I can go over again. So we want to get the x by itself, so we subtract 11 from both sides. Minus 11 minus 11. 11 minus 11 equals 0. 0 minus 11 equals negative 11. So now we have negative x equals negative 11. We want to get rid of the negatives, and remember this step. So the negatives, we can have it as negative 1 times x equals negative 1 times 11. And we divide out the negative ones to get rid of the negative ones. So negative 1 divided by negative 1 is 1. Negative 1 divided by negative 1 is 1. So now we have x equals 11. Okay, but this is not our final answer. X11 represents this. So it's saying when x equals 11 in this equation, that's when g of x will be 0. And that's fine. It's okay to have your square root as 0 because the square root of 0 is just 0. It's still a regular number. But we have to find where the square root will be negative, so we can say that the function of g of x does not exist there. So this is where we can test out our numbers. So for example, we can go one number up or one number down from 11, okay? So in one number up, for example, g of 12, okay? And we can plug it in. You can choose any regular number bigger than 11. So g of 12, g of 15, it doesn't really matter as long as it's above 11. Because remember, we're not looking for specific points, but we're looking for a range within these points, okay? So g of 12, we plug that in. Square root of 11 minus 12. So 11 minus 12 is negative 1, and you have the square root. Do not forget the square root. So now you're going to have square root of negative 1. And remember, having a negative under your square root will make it an imaginary number. So you can't have it there, okay? So now let's try a number below 11. So g of 10, for example, okay? So square root of 11 minus 10, you would get square root of 1. And square root of 1 is 1. So that checks out because it's a whole number. It's not an imaginary number, okay? This number is a whole number as well as this number. So then the answer will be negative infinity to 11, okay? And with the notation of this, remember, whether negative infinity or infinity, it's a parenthesis because it's not an actual number, it's an expression. But with the 11, it can be a bracket because it's an actual number, and you have an actual number at g of 11, which is 0. It stops at g of 11, okay? And you don't have any union, because if you go above 11, you'll start to get negatives. Because even with the g of 12, for example, what about if it was g of 100? G of 100. So then we plug that in. Square root of 11 minus 100. You'll certainly get a negative square root, right? And we can't have that. So then this is your full answer.